Hi, Avi. Welcome back.
Welcome.
How was your trip?
No, it was really good. I attended a few conferences in Las Vegas and learned a lot of acquired a lot of market intelligence, talked to a lot of potential and future customers, and saw how dynamic the industry is.
So, which were those conferences? Black Hat, DEF CON?
Yeah, so there was Black Hat, DEF CON, and another one, AI centered, which AI 4. Black Hat is the biggest conference right now for enterprise cybersecurity, and DEF CON is more for I would say more hacker-centric. Yeah, it's more for like passionate people who like to hack and to go and discover new techniques, new ways how to mitigate new attacks, attack vectors and things like that.
So it's more focused on professionals that work in this specific area, not so much in companies.
Yeah, totally. So they are all professional. Yeah, but it was way more enterprise. Black Hat is way more enterprise, and it's it's huge booth, a lot of goodies and a lot of new products released in the market, and not necessarily focused on AI, but on the entire cybersecurity industry. So it was like it's kind of a must go if you are in cybersecurity.
Yeah.
And
AI 24, that's the most AI focused one.
Yeah, and way more focus on AI, and it was very nice too, very big as well. And but mostly companies that are whether a lot of companies that actually looking to add AI into their workflow, but not necessarily have an AI integration yet. A lot of companies that were very curious about AI, but don't really know how to implement it. So, yeah, that's basically the feedback of the people I saw there.
Did you encounter anything that blew your mind? Anything that surprised you?
Like for example, DARPA was there at the conference, and so they are doing some good work into cybersecurity and the future of cybersecurity, including quantum computing, and they are looking for and they were at both conferences, Black Hat and DEF CON. They had a huge booth where there was especially in DEF CON, it's like huge villages where they simulate. For example, they were simulating a hospital and different attacks that could be made on a hospital, and you can see and on AI or not, and it was very fun. A lot of goodies.
And then did you get a chance to attack anything?
No, because I was more like watching. I was watching the people doing. It was DEF CON was more of a kind of a hackathon, like a 3-day big hackathon, like where you hack. And you hack on. There are so many villages. Some villages are hacking about AI. Some villages are hacking about healthcare industry, or you hack, firewalls, and it's huge. It was huge.
And any of the conferences that you enjoy more than the others?
Yeah, personally, I really enjoy Black Hat because more enterprise. So I really enjoy the atmosphere there. I could exchange with a lot of people in the industry, make a lot of connections, and get a lot of market insight. And
you gotta love the naming, because I instantly think of Red Hat when I say
Red Hat was there.
Black Hat.
So you can see Red Hat was there. They were distributing Red Hats as goodies with the Red Hat logo, and Red Hat was there. There was many companies, even Claro was there. Claro, there were many cybersecurity companies, from Microsoft to Checkpoint to everybody was there basically.
So we are in this moment in which AI is in the center of every conversation. We are all talking about AI, how it's going to change the world, how it's going to boost everything, how it's going to destroy us, whatever. But if we go into the business side of things, and you mentioned that Black Hat was the one you enjoyed the most because it was the more enterprise-focused conference, how would you say would be the way to boost a company's profits using AI? How can AI be used to boost profits?
Yeah, so before I answer the question, I think that it's worthwhile to mention that a lot of companies are not aware of how they can boost their revenue with AI.
Of the potential, or of the methods?
Of the potential.
Okay.
So there are, we can see that we are at the infancy of this growing industry, especially with the advent of generative AI. A lot of companies are thinking to implement it or have implemented, but they are not aware of how to improve it to, one, generate more profit, two, protect from threats, and three, preemptively protect from financial cost and reputational cost due to future regulations that are coming. And that paves the way to a huge opportunity, because we're surfing on a wave right now of generative AI, which is great. A lot of companies want to implement or have started to implement, but it's still making a lot of errors. So how do you mitigate those errors? How do you save costs, not only financially, but reputationally? And how do you tap into this beautiful new data potential that you have conversing with thousands of customers or your employees? And how do you make sense of all this data to, for example, detect customer intent, or predict what your customer is gonna, what product is gonna consume next, or if he's gonna leave the company? So this is our problematic that I thought a lot about, and we are thinking a lot in ultra deep tech, and we think there's huge potential here.
You know, you remind me of an experience that I had recently, which I mentioned to you, which was with a chatbot, a user satisfaction chatbot. Right, I was trying to solve a problem, and instead of having a human, I had a chatbot to interact with, and it was very poorly implemented. It wasn't resolving anything, and I was very surprised because, I mean, for us, maybe that we are into the technology and the nuances, we know that this could be solved. But this chatbot that was providing me a very poor experience affects the reputation that the company has towards me, and probably towards lots of other clients. So this ability to have information on whether your customer is happy with your chatbot and with your technology, it's crazy that it's not implemented in the whole industry, right?
Yeah. So you can see that it's starting to be implemented, but a lot of, from what I noticed, a lot of companies don't have a holistic view on how to have facilitate the customer purchase, in a sense that because we believe that our customers, what they really want is to have it clear how they can increase their ROI, and how they can reduce their cost and they increase their customer satisfaction. But a lot of companies don't have this holistic view where they solve that specific problem as a whole. And so for me, it's the most important thing to make it clear for the customer how they can solve it. And that's why we are very focused on the technology right now, because there are a lot to do and a lot of innovation. We're developing a lot of proprietary technology that goes beyond what you can find out there, because these are hard problems to solve. And we are constantly updating, it's like a cyber security company will constantly update their product. And that's very important in my opinion.
And so going back to the question of how can a company boost their profits with AI? I mean, you mentioned this focus on monitoring the client satisfaction through monitoring of the conversations. You mentioned being aware of the possible threats that could be placed on your models. What else can you tell us?
Well, there are many ways you can boost your company revenues, but in the context of AI, I guess there are different ways to look at it. One way to look at it is to regularly measure the progress of the AI that you implement. So it's very important to have a way to benchmark and measure accurately your success and your progress. Because by measuring and by improving your models consistently, and then you can increase. That's the source from which you increase your customer satisfaction. That from which you increase by a few percent every quarter. You increase your revenue by predicting better your customer intent. And so it's very important to be able to do that on a systematic manner. Another way is to use the appropriate technology. I would give you a simple example. Machine learning versus deep learning, for example. Depending on your use case, you would have to know if using machine learning, which is more cost effective, that can solve the problem more rapidly. For example, if you have a lot of structured data, rather than deep learning, where you invest more money in the upfront, but you can solve the problem to the long term.
What's the difference between machine learning and deep learning?
So machine learning is more of a technique where you work more with the structured data, and it gives systematic answers. And what I mean by structured data versus unstructured data is that structured data is data that adopts usually the same format that is fixed. Take example of a database of customer name, first name, last name, email, and all kinds of data points. But the data is kind of structured, and you can employ machine learning algorithms, which are more like rigid, and you can design your own features, and then you get the results based on that.
Because you mentioned databases, and I'm thinking of relational databases and non-relational databases. It has something to do with it? Is it a good analogy, or?
Not really, because databases is a kind of a structured data, but the fact that it's relational or non-relational, it's just secondary. What I mean is, like, when you have deep learning versus machine learning. In deep learning, we use data that's more like images, or that vary in format, in size. So when I use a deep learning algorithm to doing object classification, for example, I can use different size of images.
Okay.
Or,
So there's no particular requirement on the input.
there's less rigidity on the input, and also the algorithm are much more flexible in terms of feature engineering, which means that when I use deep learning, I don't need to decide how my algorithm will make sense of the data.
Okay.
It finds its own features. And sometimes the features are not features that are understandable by humans,
Okay.
right? So, and that's why it makes deep learning algorithm more of a black box that we don't understand. Like you can see a generative AI, large language models right now, we don't really know exactly how they work.
Okay.
Versus machine learning algorithms, we have specific machine learning algorithm like random forest, like trees algorithms that you can know exactly what, for example, feature importance, and you know what feature makes your algorithm, determines the result of your algorithms.
So underneath all of this that we're discussing, there's neural networks, right?
For deep learning, yes.
Only for deep learning.
Yes.
So machine learning doesn't use.
No. And so that's basically the simplification you could roughly make is like deep learning is almost equivalent to neural networks, basically.
Okay. How would you define a neural network in this context? For someone that doesn't know anything about artificial intelligence.
Well, look at it that a simulation on the computer of a human brain. Human brain is made of a network of neurons. We have managed to simulate roughly the functioning of a network of neurons, but in the computer. It's a little bit different, but the principle is the same. So if you look at the baby, for example, that's just born, his neural network, he has the architecture in his brain of a neural network, but it has gathered minimal amount of data, but it's optimized to just get data in and make sense without intervention of humans. It can make sense by itself of the world around it. So in the case of a baby, for example, first thing that he learns is vision. And the first 6 months of the life of a baby, the baby is blind. So it doesn't really see. But he's taking in millions of images in his brain, and his brain makes sense of shapes, textures, angles, and it's very similar to the way a neural network works. So in computer vision, for example.
So humans learn to see within the first month of life.
Yeah, totally.
That's very interesting.
Yeah. So that's the same principles when you learn. We say learn a neural network. You just feed it, and it learns the angles, it learns the texture, the shadows by itself. And then you can fine-tune the neural networks, and that's how it works. Very similar to a human.
When you say fine-tune neural networks, what do you mean? What's that fine-tuning?
There are a lot of ways to fine-tune neural networks, but for example, on the same example of the baby learning vision, at the beginning, the first steps are to learn lines, angles, round shapes, textures, shadows. And then once you make sense of shadows, you might be able as a baby to see, there is an edge, and then I might fall. But you still, when you see babies falling from a table, they are not afraid because they haven't made sense of gravity yet. They haven't made sense of falling. So they had to they have to experiment the act of falling 1, 2, or 3 times.
You cannot feel pain if
Right.
if you don't know that.
Right. And so that's how they experiment gravity. And it's very interesting to look at babies to understand how neural networks work, because they are very interesting to look at. You can look at their progress. So a 6 months baby, it doesn't do the same things as a 3 years old. That doesn't do the same things as a 7 years old. And it's so interesting to see all the steps that it goes through.
You're speaking about babies and neural network works, and I can't avoid thinking, what age does AI have right now? I mean, the current state of the art of AI.
So interesting. So I always say that AI, for me, it is alien intelligence. So while there are many commonalities, I think there are ways from which AI is made that is a bit different from humans. For example, we have developed AI in many different areas, computer vision, or for example, image object detection on images. We have text. We have a lot of different branches. Our brains aggregate all of this together and links all of it. So that's, in a way, it's different. Only recently with generative AI, we have been able to do multimodal. So if you ask me how old is the generative AI, I think maybe the age of I would say the age that comes to my mind, 7 years old. But in some areas it can be older. In some areas it can be younger. And again, it doesn't have all the motricity, all the things that humans have.
Yeah, and we don't know how it's going to be when it's a teenager or a full-grown adult.
Yeah, and I think it will very quickly outgrow humans, very quickly, in ways that we don't imagine yet, we can't predict, but it's going to outgrow humans. In my opinion, humans, in the scale of intelligence in the universe, I think we may be at 2% of the capacity that we can reach, if not much less, but
yeah. There has been lots written and lots said about artificial superintelligence. When do you believe that we're going to reach this singularity? If that's yes, right? If that's yes, when do you think that we're going to reach that? In what point in time?
This is always a subject that's very hard to talk about. It's a bit like quantum mechanics. The more you think you know about it, the less you know about it.
Of course.
But I always refer to Ray Kurzweil, that is one of my favorite futurists. And that he says that by the year around 2045, singularity will happen.
Kind of far away. Because
yeah.
There are others that talk about 2030.
That's for AGI.
AGI, okay.
Yeah, that's for AGI. So
which AGI means artificial general
intelligence. Some people, it's even Ray Kurzweil himself has rectified his prediction to be closer to 2025, 2026
for AGI.
For AGI. But again, I think that there are different vectors of AI, and I think that ultimately they'll converge. Like robotics, for example, is emerging like very powerfully, and it adds all this dimension of movements to visual data and audition. It gathers everything, and then you can grow even faster, because when you have multimodal, and it's been shown that multimodal models cross domain, meaning that they learn from one domain, they will benefit another domain.
What's the definition of multimodal?
Multimodal is an AI that can learn from all types of many types of data.
Okay.
Images, videos, text, audios. You can feed it all of this, and then it can learn and make correlations.
First, you said earlier, you said that deep learning allowed for different inputs that were unstructured. So are all deep learning models multimodal?
No, most deep learning models right now are unimodal. So it's only very recently that we have multimodal inputs. And the reason why is because we have been able to, by the simple fact of vectorizing the input data, by different techniques, you are able to vectorize audio, video.
What do you mean by vectorizing?
Meaning that when a neural network is still an engine that takes numbers as an input. So when I say vectors of numbers, is just a simple list or matrix of numbers that represent the input data. An image, for example, is a matrix of whatever 600 by 480. That's the size of the image. It's a matrix of pixels and colors of the pixels. So when I say vectorizing, it's a bitmap, and you compress into a vector, an image or a sound, and ultimately it's in this vectorized language, images or text or sound speak the same language.
Yeah, it's a translation process in which you take different kinds of input and give them a unique word, let's say, which is the vector, a unique word that can be understood and processed
totally
in the same level.
And by the way, that's something very interesting fact. What you just touched on is very interesting, and it's absolutely revealing of the nature of our universe, because you realize that images, sound, text, when you translate them into this vector language, they can communicate. They speak the same language. And we have found out that the same happens through different languages. German, English, and even more than that, we have found out that even animals, animal communication, fit this kind of similar pattern. So right now, the cutting edge research, it's about how we can communicate with animals, for example, because the concept of food, the concept of survival, the concept of mating, those are universal concepts among biological species. And so you realize that actually everything is connected in terms of, because it's all of it represents our condition in the universe. And somehow it connects in many different dimensions. So it's super interesting.
I don't speak Chinese. I think you do. But that in Chinese you have ideograms.
Yeah.
You don't write with words, you write with ideograms. And for what I understand, people from different parts of China maybe don't share the same exact language, but they share the ideograms, so they can understand each other. And this ideogram, I'm reminded of this because these ideograms are sort of vectors that represent ideas, independently of how those ideas sound.
It's very, very well put. These ideas, they are symbols, and it's extremely well put. And by the way, if I may make another comparison, it's like if I give you the concept of, let's say, a tree. In your mind, you kind of visualize like what a tree looks like. If you close your eyes, you imagine a tree.
Yeah.
You can have the contour of a tree, but this tree that you visualize can represent an oak tree, a bamboo tree. I mean, that's the compressed format. That's the compressed vector that your mind uses basically to identify the concept of a tree.
Yeah. You have a shape, you have a color.
Yeah.
And that's a tree.
Yeah.
And that's what kids draw. When they're small, and you say, draw a tree.
Mm-hmm.
They draw something brown, something green, two shapes, and that's a tree.
Right. And what did I say? I give you the sound. Draw me a tree. And what did you do? If I tell you, imagine the sound of the leaves of a tree in the wind, what do you visualize? A kind of a similar symbol that if I talk to you about the word tree, T-R-E-E, that's the word, but they all kind of come back to the kind of same vector, the same symbol, whether it's from the sound, whether it's from the vision, whether it's from the text. And that's what a neural network does when you talk about multimodal. It all boils down to the same kind of vectors, and then you can compare those vectors, and somehow it coincides, and that's why you can have all those wonderful things happen in generative AI and multimodal models. Yeah,
and that's why it can very easily translate between languages, and that's why
you got it.
You can provide an image, and it can understand the image and say, "Hey, this is a tree."
Exactly.
Because it matches vectors.
Yeah.
What determines the capacity of an AI, the ability of an AI of interpreting more vectors and combining more information and giving better responses to whatever problem? Is it the computing? Is it the algorithm? I'm guessing it's both, but what can you tell me about this?
What mainly gives the capacity of an AI is it's a combination of things. It's the computing power, the size of the data set, and the size of the AI itself, the neural network. Actually, OpenAI released about in 2020 a paper showing that with the architecture of transformers, which is the architecture that took off the huge wave of AI, of generative AI, etc., you can scale almost linearly with the size of the neural network and the size of the data set. And so those three components, computing power, size of the data, and size of the neural network, are three components that scale and give the capacity of the AI. And we haven't found an upper bound yet.
You mentioned the size of the neural network. Maybe this is going to require that you explain a bit how a neural network is composed, but what determines the size of the neural network?
How many neurons you packed into it.
Okay. And what is a neuron in this context?
Not only the number of neurons, but I would say more the connections between the neurons.
Okay.
You can connect one neurons to 1,000 other neurons, or 1,000,000 other neurons, or 10 neighboring neurons. So actually, when you talk about the weights of a neural network, actually we talk about the connections between neurons. And that's a bit the same in the human brain. Like you have the neuron connections, but there are much less neurons than there are actually connections between them.
I'm thinking of the Metcalfe law. This guy worked at I don't know if it was Bell or which telephone company, and he thought of a formula to predict the number of connections between different. So given the amount of telephones in a network, how many connections there were? So it's a power of 2 or something like that.
Yeah, that's a complex branch of mathematics.
But the growth of the network is exponential. That's
Oh yeah, yeah. Definitely.
So I'm thinking of how large is the neural network in our brains compared to the size of the neural networks that are currently.
Oh yeah, good question. So, in my latest knowledge, the number of connection in the human brain is about 100 trillion, if I'm not mistaken, in this order of magnitude. And the number of neurons, it's about, I think, 100 billion. And so you have about an average of 1,000 connection per neuron. And if you look at the number of parameters of the latest large language models that we have, it's getting closer. So it's about in the order of the trillion or tens of trillions of parameters for the very latest that I think they are still in research development, but they are about to be released. GPT-5.
Okay.
So we are getting to one order of magnitude difference.
Okay.
So it's getting very close.
That's very interesting.
Yeah.
Going back to the conferences, because you mentioned everything very business related in your experience. Did you see anything on the technology side of things that strike you as interesting? Any new developments? Anything that you thought, hey?
Most of the companies won't talk about their
research and
development, innovation, tech that they have, but I think that's very interesting. Part of the work that is done right now in our industry is that we are entering a very new kind of research and development phase. And this is only me saying, because this is not only, but this is me saying, because what I believe is that AI and deep learning is getting closer and closer to what I would call a psychology, human psychology. And so in that sense, while there are still a lot of research from the academy and the industry out there, you need to be a little bit smarter and swifter, I would say, in the way you approach technology, especially when it comes to generative technology surrounding generative AI. Why? Because it starts to get closer and closer to how a human behave in the world. Let me give you a simple example to make it clear and to make people understand. It's for example, when you want to protect for hallucination, and our company is actively working on those field of research. And the striking thing that I noticed at the conference, or usually with our competitors, that they approach the subject in a traditional manner, like it's been done in the 5 or 10 years ago. But I believe we need to rethink the way we approach it technologically, and to have a mix between traditional deep learning technologies and AI ways to solve a problem, normal algorithmic solutions, but we have to think also about how the human brain works. Because if I ask you to correct a human hallucination, for example, human hallucinate as well. Like it's not only.
Actually, there's a book. I don't know if you've read it. It's called The Invisible Gorilla.
I haven't, but I would love to read it. Yeah.
Okay,
Give me the references. Yeah.
yeah, I'm going to spoil the book for whoever is listening, so be aware. But it's all based on an experiment in which they presented a video to some people. In the video, you saw different people passing a basketball, and the interviewer said, "Count how many passes they do among the black shirts or whatever." And so they count. In the video, there's one guy dressed as a gorilla that passes through everyone passing the ball, and most people don't see the gorilla.
Yeah.
And then after that, the book dwells into what perception is, and how we believe that we see our world, but we actually don't. We reconstruct what the inputs are, and we build an image, a story. Our memories are all reconstructed and are not that trustworthy. You don't see when you're driving. You don't see motorcycles because your brain is expecting to see a car.
Yeah, I love that analogy. It's beautiful. It's totally. It's totally that. I would love. I know which video you're talking about because I've seen it too, and it's like I fell into that.
It works.
It's unbelievable.
It works.
So so more and more
you see what you're focusing into.
Yeah.
If you're not focusing on something, your mind blocks it, which makes sense because there are so many stimuli in the world that you cannot gather all of them. It happens with advertising. I don't know the numbers because I don't remember that, but every day you see a number of ads that you cannot imagine. And you maybe remember 1, 2, 10 of them. And that's because your mind filters. And that's to protect you.
Yeah, no, that's
not from ads, but from an overwhelming amount of information that's in the world around us.
Yeah, no, that's so interesting. That's a super good example of how you can link human intelligence and biases to what is coming, and it's coming. So the research needs to be updated, and so we are here in the front, and we believe we are a dynamic company, and we are actively targeting these ways of doing research and implementing it in our product, so that we bring to the world the best innovations. That's for me the new way to innovate in AI.
So I think that we can close on that note. It's been a very interesting conversation.
I thank you.
Until next time.
Yeah.
All right.